anything. And please don't feel like you have to turn on your camera, but we greatly appreciate it. It makes it feel more like a class that's like in person. We're supposed to be in person soon, hopefully, fingers crossed. So it's just greatly appreciated if you do keep your camera on. You don't have to if you don't want to, though. No pressure. Plus, it helps it make it feel a little bit more like in person. And by then, I'll be able to get your names associated to your faces. By the time we get in person, it'll be great. Love it. So let's go ahead and get started because we got a lot to talk about today. You're in the Python DeCal. If this is not the class that you thought it was, then I'm sorry. Somebody told you bad information. This is the Python DeCal. We're gonna teach you Python in this class. So stick around if you want to learn that. You don't have to if you don't want to, though. This image was taken by a previous instructor. His name's Elon. He's a sweetheart. Love him. He helped with this, and he made all the really pretty images that you'll see on the start of lectures. I don't know where this is. This might be in China or in the Bay. Can't really tell. But yes, there'll be lots of really cool images. And there's a comment that was like actually taken. Anyway, we're gonna do introductions. My name is James Sunseri. I'm the head instructor for the course, but we also have several other instructors and interns helping out. And there will be more on them after I speak. A little bit about me. Am I recording? Yeah, okay, good, I'm recording. I use he, him pronouns. I'm a fourth year astrophysics and physics double major. Probably gonna be here for a little half of a fifth year too. So I'll be here for a while. Can't get rid of me that easy. I'm a mega nerd. I love comics and superheroes, and I will argue with anybody any day about anything comics related. DC's better than Marvel. Can't change my mind. I'm an amateur guitar player, ukulele player, and I'd like to say I'm a piano player, but that's not true. I know like 3 songs that I spent like 10 hours on YouTube learning how to play. But I love music. It's super fun. So if you are musically inclined and interested, I love jamming with people. Sometimes I bring my guitar to campus and play. So that's a little bit about me. My research interests. I'm into like everything extreme with astro related stuff. So gravitational waves coming from neutron stars and black holes, magnetohydrodynamic simulations. So like if you put like magnetic fields and electromagnetism and slap it into a simulation of some hot fluids going through space and gas, that's like what I like to do. I do observational and a little bit of theoretical cosmology, looking at simulations of the entire universe. It's pretty cool. I dye my hair crazy colors sometimes. And on the right is a bunch of pictures about me. This is Elon, the sweetheart that took a picture and made the wallpaper for the start of the lecture. Sometimes I dye it blue and purple and braid it and sing with friends and stuff. So that's about me. The next instructor is Raphael. Take it away.
Hi, I'm Raphael. I use he, him, his pronouns. I'm a fourth year astrophysics and physics major. Yeah, my research interests are mainly in supernova, light echoes, and stuff like that. Variable stars too, a little bit. And besides that, I like to play soccer. I'm the co-president of club soccer. Tryout starting next Monday. If you want to come out, let me know. So yeah, exciting. Before we even have classes on campus, I don't know, but apparently. So yeah, that's me.
Hi, I'm Emily. I use the she, her, hers pronoun. I'm a senior. I'm studying astrophysics and computer science. So some of my hobbies are running, jigsaw puzzles, as well as like drawing and painting. And some of my interests on the astro side are like planetary science and like atmospheric simulations and stuff. And then also on the CS side, I'm really interested in computer graphics and also making my own video games.
And Emily is going to work for Roblox. So if you like Roblox, it's lit. I'm sorry. That's a really cool flex. I have to do it for you. Isla?
Hi, everyone. I'm Isla. I use the she, her, her pronouns. I'm a fourth year astrophysics major. Just some of my likes: backpacking, hiking, animals, plants, rocks. Also, just got really into growing my own edible mushrooms. So I have like this little like set of oyster mushrooms that are growing. So if y'all are interested, I could show you sometime. They're pretty cool. Yeah, pretty cool. Mushrooms are sick. Anyway, this is about astro though. My astro interests are supernova and kind of on the opposite end of the spectrum, solar weather forecasting. Yeah.
Hi, my name is Megan, and I use the she, her pronouns. I'm a sophomore intended astrophysics and applied math major. I really like music teaching, and I really like anime. So if you guys like anime, we can talk about that. And so my research interests are cosmology and stellar evolution, but lately I've been looking into exoplanets and instrumentation. Yes, I have a cat, but she's not in my apartment. She's at my house.
All right, so that was the staff. They are like the teachers, like the full-time teachers. Think of them as like if you had 5 professors running a class, but we're not professors, so we gotta like kind of team up and like it's like the Avengers, you know what I'm saying? Anyway, so following is the interns. So these are students that took the DeCal last semester and did really well and cared about it and wanted to come back and help teach it. So introducing our first intern.
Yes, hello, that is me. I am Claire. I'm a freshman, so I'm intended astrophysics major and also planning on pursuing an EAST minor, so we'll see how that goes. I dabble in a bunch of random stuff. Some stuff I like to do, I like hiking, I like rocketry. If anyone's interested in that kind of stuff, you should all join Space Enterprise at Berkeley. I don't make the rules. Robotics, D&D, and tabletop gaming, drawing, graphic design, making music, singing, playing instruments, all that stuff. Here's some random photos. I build random stuff in my free time. So usually random high voltage stuff. If you're interested in that kind of thing, you should talk to me. I want to work on stuff. Astro specific stuff. I've done some research on exoplanets and stellar systems. Currently doing some research with detecting dark matter. So that's fun stuff. My other interests are spacecraft and instrument design, and also I'm quite interested in studying lightning and other spooky atmospheric phenomena. So that's me. Hello.
Hello, everyone. My name is Annie. I'm a junior transfer and astrophysics major, and I'm also pre-law. I thought I would just mention that. And I do martial arts on campus. I'm part of the Wushu Club, so highly recommend joining, even if you're a beginner. Lots of fun. I dance, I bake, and I love playing old Mario games, as you can see from the picture there. And yeah, I'm interested in stellar death and black holes, astrobiology, and criminal justice.
Hi, my name is Maham. I use she, her pronouns, and I'm a first year astrophysics major. My hobbies include, but aren't limited to, theater. So if you have any like musical recommendations or anything that you have performed in, I'd love to hear about it. I like running, but away from my problems, but I also just like running in general. I also love just like going outside and exploring. Like I've really like taken the BART system to my advantage here. And my research interests that I would want to pursue are black holes and also like dark matter and energy. The pictures to the side. So like when I first came to SF when I was super young, I had a bag of Cheetos in my hand and like someone snapped a picture of it. And then I just randomly bought a bag of Cheetos and I wasn't planning to go to the Golden Gate Bridge, but then I did. And then it was a cool picture to take. So that's why I included it.
Awesome. So, so that's all of the staff. That's like a lot of people. There's 8 of us. We're probably like the most like overstaffed class, but we do it because we want to make sure that your experience is as smooth and as great as possible. So the interns are, you know, like they're more like the GSIs or that you would you know, in a normal class. They're like the equivalent of a GSI. So their job is to come to help office hours and facilitate them, answer questions you have on Piazza, you know, grade your homeworks and do all sorts of stuff like that. This is a pass no pass graded course, so we have a lot more flexibility. We don't have to be like super careful about, you know, grade boundaries and getting close to the staff. Like we're like friendly here. My goal is always to make sure everybody passes. It's getting harder and harder to kind of help people if they need a little bit of hand holding to get out of a rough spot, because there's so many people in the course now. So it's kind of a good thing, kind of a double-edged sword there. So we will do our best to keep you moving along, but if you ever feel like you're falling behind, need help, please reach out to us. We're gonna have so many office hours for you to pick and choose what you want to come to. We have like a very big support network here, 8 people to help you out and do whatever you need to do. So, you know, we want to make sure that everybody learns how to code in Python, enjoys doing it, hopefully, and leaves this class feeling like you actually gain something from it and not being resentful of taking it. So that's our mission. If we're not doing that, let us know. There'll be ways to, you know, give us feedback anonymously. I'll make sure that we get all that stuff sorted. But now we're gonna move on because we got a lot of stuff to talk about. Icebreakers. No, I'm just kidding. We're not gonna do that. Not over Zoom. That shit's ass on Zoom. We'll wait till everything's in person to do that. So yeah, we'll 2 weeks time, you know, fingers crossed, everything's all smooth. We'll go back to in person. We'll do some icebreakers. We'll make a dope playlist for the class. It'll be a lot of fun. I'll try to make the icebreakers a lot more interesting than other classes. We're not going to just do like share your name and your favorite cat or something. It'll be more fun. So I want to get into what's the point of this class. The point is as follows. These are the goals that we set for the course. I kind of mentioned them already, but this is a more explicit outline. Just the bullet points though. Over the span of the semester, we're going to try to teach you this, the fundamentals of how to program, or how programming works. That includes like, what is a data type? What are functions? What are iterations? What is conditionals? These are all things that, yes, we're going to learn them in the context of Python, but they apply to every programming language with some exceptions. But almost all programming languages that you will use ever in your life or want to learn use these kind of core ideas. And this is how programming works. And this is how you convert your brain ideas that like, whoa, wow, wouldn't it be cool if I could do this, into actual code that'll do stuff for you. We're going to learn it through the Python language. So we're going to learn all your Python syntax through that. It's kind of like a joint combination of how we're going to learn it. It's got some quirks to it. We'll learn those quirks. Luckily, Python is designed to be as readable or as comparable to English as humanly possible in a programming language. So it reads very, you'll see what I mean. When you say you want something to be 7 or X to equal to 7, it reads like that. It's very readable. And the reason for that is because it's a high level language. I'll get into that next lecture or whatever. But it's a very nice, easy language to start on. It's not easy to learn, but it's one of the easier ones relative to everything else that can be a royal pain in the rear to learn. So Python's a great starting language for y'all. Then we're going to develop your skills relevant to STEM fields that use Python. So once you learn the very, very basics, then we'll start feeding in some fun stuff. This is the stuff that does not get covered in a typical CS class, but somehow is expected in your upper division physics classes that nobody teaches you. That's what we're going to teach you. So that's things like how to make plots with Python and data. You know, if I have some measurements that I took in the lab and I make a spreadsheet of that, how do I turn that into a plot that somebody could look at? You know, giving somebody a table is ass when you're trying to communicate information, but a plot is like worth 1,000 words. So showing somebody an image of a trend is a lot better. So we'll teach you how to do that. We'll teach you things like numerical methods, how to do a numerical derivative, how to compute an integral like with Python, how to find the roots of a equation, how to simulate differential equations, how to find trends in your data with a curve, how to fit like a model to that data and figure that out. These are all things that don't really get taught in CS classes, but are needed in any STEM field. And not just in STEM, honestly. It could be in basically anything that includes data. If you're going to be dealing with data, you're going to need to know how to do that. Then we'll get into some fun, cool things that we kind of, like pick and choose what we've really loved learning over the span of the 4 years. That's for me, in my case, we're going to give you a little bit of animation, a little bit of simulations, how to simulate stuff. We might talk about machine learning if there's time. Y'all will really actually get to be able to pick and choose what we kind of talk about. So we'll give you a list of special topics, and that's where we get into the fun, cool things that hopefully you'll really enjoy now that once by that point you have the skills and the know-how to code the basics in Python, you can appreciate it. And then career and development stuff. So these are going to be kind of intertwined, but by the end of the course, you should be able to write a CV. If you don't know what that is, you'll learn about it. You'll be able to make a personal website to like display all your accomplishments and stuff. It's very professional and kind of, what's the best word to say? Unique. That's the right word. It's unique. It's very rare that in an application you'll be able to, or like somebody will see, oh, personal website, let me click on this. Oh, wow, it's a whole portfolio. It's got all sorts of links to their web designs and, Python projects and all that cool stuff. So we'll do that, and we'll talk about basics of, research etiquette. How does it work? How do you get into it? We'll give you a little bit of career development in that respect. Some of this stuff won't be applicable to you. We have a very diverse course or set of people in this course, ranging from MCB to physics to astronomy to finance to data science to math. It's everywhere in that whole region. So we are excited to get everybody learning Python. That's the goal. Is there any questions about the course goals? All right, I don't see anything. Cool. So then we're going to move on to some cool stuff you can do with Python. Just really quick, this isn't like we're not, oh my gosh, I don't know how to work with this. Okay, that's fine. This isn't like to like teach you anything yet. I'm just showing you what you can do. So this is an email. You might recognize it. It's the email I sent to you. I used Python to make that email. I wrote an auto emailer with Python to send to everybody who filled out the Google form to sign up for the course, to save me time writing 60 emails. It's a little unnecessary and a bit overkill, but it was pretty cool. So I used Python to do that. You can use Python to make pretty plots. I'm not going to try to explain what this is, but it looks pretty, and it's for a cool presentation that I'm working on in a research project, and it's blue, white, and red. It looks kind of cool. You can make simulations in Python and animate them. We'll talk a little bit about that. Maybe not exactly this, but this is like fluids moving next to each other and what happens when you wiggle them a little bit. It's pretty cool. It's called the Kelvin-Helmholtz instability. Or if you're getting really into it and you find that you really like animation, you're like, whoa, there's actually software that you can use that's, cutting edge. Like that's what they use for like CGI projects and movies and stuff. And you can actually use Python to do simulations that would be like used in like a film. So this is like a program called Blender. And it's like they did like a simulation of collision physics of boxes and stuff. So all sorts of really cool stuff you can do with Python. And it doesn't just kind of only work for like, making plots or like doing a little basic function or anything like that. It has a very wide range of applications, even in machine learning. If you want to teach a computer how to read text, that's typically done with Python. There's a whole bunch of other options out there for you. So we're excited to kind of, hopefully inspire you a little bit. Oh, I almost forgot. Since this is like taught from an astronomer's point of view, we have to include pictures of space. So there'll be lots of examples of like, this is a real telescope image that we took in my research group of a galaxy. I don't really know what galaxy it is, just a galaxy, but we use Python to make that image with RGB filters and stuff. So it's pretty cool. You can do a lot with Python. That being said, let's go ahead and get into the syllabus. This is super fun. Yeah, I should be able to just do this nice and easy. So if we just go straight, can everybody see the web page? Cool. This is B courses. You know how to use it. I'm not going to explain how to get there. Hopefully you know how to get to B courses. But I will admit though, okay, hold on. I figured out how to make the course picture move. I don't know if y'all can see that. It's moving. I'm really proud of that. Sorry. That was a little detour. But this is the course homepage. I like GIFs. They're like everywhere, wherever I am. So if you like moving images, you'll be in luck. And I put like memes on like every one of my slides. So you'll know, it'll be fun. It'll be fun. Anyway, here is the instructors and interns names. If you forget them, we have the link on the homepage, right when you open it up. There's a password. Did y'all have to type in the password to get in? Cool. That doesn't work. But if you did have to type in a password, it would be this one. Then after every lecture, our goal is going to be to record the lectures and then post them to YouTube. That will not always happen because we are only human, but it will be our goal. Originally, we were only going to do this for the first 2 weeks, but then I'm like, all right, what are the odds that it's actually going to be only 2 weeks? So we'll just do it for the whole semester. We'll just do it. We did it the last 2 semesters. We'll just do it one more time. Hopefully it won't be that difficult in person, but all the lectures will be recorded and uploaded afterwards. On top of that, we'll also post the slides to the B Courses website so you can look at them. So if you do miss a lecture because you maybe have a time conflict or something, it's not the end of the world. It's not ideal either. So try to get rid of your time conflicts. That is a bunny. Annie's, I couldn't help but look at Annie's thing. There's a bunny in there. But try to make sure that you can come to lecture every time, because coming to lecture is far more valuable than just watching the recording or looking at the slides, in my opinion. It allows us to feel more like a real class. It's more encouraging when people show up instead of not coming. So we appreciate it if you could do that, but you don't have to if you really don't want to, or you can't do it, or whatever that is. That being said, we will have a form of keeping attendance. Part of this course grade to pass this class is keeping up your attendance. So usually we'll have some sort of form for you to fill out for every lecture. They're not hard or anything. It's like, what color is or what's your favorite color or something, and then that's it. And that's like just for us to know that you filled out the form. Maybe we'll ask you one question about the lecture to make sure you watched the lecture or look through the slides, just so we know you're getting the material. I don't want to pass people in the course if they didn't pay any attention to what we were doing and have no idea what's going on. That looks badly on us as a staff, because we're building a reputation that the DeCal is like a really, really good resource for Python, and people that leave the DeCal are arguably some of the most prepared people for doing computation in STEM fields. So that's what we're trying to do here, and we want to make sure that we uphold that policy. So please keep track of attendance. We'll explain more on that a little bit later on our next lecture, but please come to the next lecture and we'll walk you through that. But there'll be some sort of form for you to fill out to count as attendance. Office hours, those haven't been decided yet. I hate it when professors just pick an office hour time and then it doesn't work with anybody, and you're like, all right, well, that was not cool. So we have 5 different office hours. We're going to send out a when to meet. Y'all are going to fill it out. Let us know what times work best for you, and we'll try to match it with our schedules and have 5 different office hours that everybody should be able to make at least one of them. That's the goal. So these are to be determined. They'll be announced probably sometime next week. We'll also have a Piazza. We typically have like Discord or Piazza. We had Discord last year or last semester, and there's a lot of complaints about not being able to post anonymously very easily. So we're going to stick with Piazza this time. That way y'all can ask questions without having the burden of feeling like everybody's watching you and criticizing if your question is dumb or not. Although there is no dumb questions here. I want to iterate that. So there's the Piazza. And then there's Jimmy Fallon telling you welcome. The files, this is where you'll access your homeworks and your homework solutions and everything that's going to be in the course. We'll post lots and lots of good stuff here. There's a syllabus if you want to take a look at like the actual documented syllabus. But I'm going to go to our other website that we have. This is not really required to do anything in the course. It's more or less for recruiting, so we can just give you that one nice link to go to and check it out. I hope all of you checked it out already. It's called pythondecal.github.io. This is like the homepage. On it, there's lots of final projects. Last semester, we have lots of good stuff here, like Voyager Golden Record projects. You can click on any one of these images and it'll download the entire package that we were submitted to us. So you can check out their videos and their code and all that cool stuff to take a look at once you feel ready to do that. But my point for going to this website is that we have the curriculum posted right on a tab. So if you want to look at the syllabus, it's all right here. The grading breakdown, 10% participation. So that's filling out that form after every lecture. Homework, 60% of your grade. Homework is very important. I want to stress this. Do it because it's how you'll learn. You're not going to learn super easily. You know, I'm not going to just explain it to you in Python on a lecture slide and you'll just magically become good at programming. It's like any language. I'm sure you've heard this before. You have to use it in order to get good at it. You know, I can go to a French lecture for, you know, an entire semester, but by no means will I be ready to go to France and speak like a native afterwards. You need to use it to do it. So yeah, don't worry. We'll be downloading, or we'll be showing you how to get all the Python stuff ready to go at the end of today. And then, so 60% homework and then 30% final projects. That's a total of 100%. I think I can, yes, that's 100% I can add. The final project is mandatory to pass the class. So even if you did do the participation in the homework, got 100% on that, you still need to do the final project to pass the class. A final grade of above 70% or more will count as passing. It's not very hard to pass the class. You just do the homework, or at least try to do the homework to your best of your ability and do the final project. That's all. That is what we need. You know, participation is also required too. So if you just kind of give it an effort, no need to be perfect. Don't worry. We're not harsh graders by any stretch of the imagination. If you lose a point, it's because you got it wrong, or two, it's out of 100 points. So it's not hard to get like above, you know, like a 90% or whatever, but we don't grade any by letter anyway. So it's just pass, no pass. That being said, if you miss a couple homework assignments, it's not the end of the world. We would really appreciate that you did all of them so that you learned. They all have really valuable information, and they kind of serve as guides in the future. Every homework assignment that I've done with coding, I have gone back to when I needed that information and then just copied and pasted into my own workflow that I'm doing somewhere else. So doing it, giving your best attempt at it will help you tenfold rather than not doing it. But we understand everybody's human. So we'll offer 2 homework drops free of charge. If you have to miss, you have to miss, but we'll offer 2. I didn't write that in the syllabus because I'm making it up as we're speaking. Last semester, we had a lot of difficulties with students missing 1 or 2 homework assignments, and we just don't want to deal with it. So we're just going to give you 2 drops. That's it. 2 drops. Easy. Okay, cool. Class will be every Monday, Wednesday, 3 to 4 p.m. Please cancel any other conflicting time conflicts. We would appreciate it. It's easier on you. If it's really if you have to miss 1 lecture every week, I would consider either dropping that other time conflict, or possibly taking the DeCal next semester. We should be offering it next semester as well. So that's always an option if you do have the time conflict. It's not the end of the world if you have to, but it might be better for you to do that. Cool. And then here's the week by week syllabus. I'm not going to go too in depth. All the bullet points that I talked about the main goals of the course are in here. We'll start very easy this week, just getting you familiar with downloading Python and getting it installed on your computer. So everybody should not leave today without having a working version of Python on their computer. And we'll talk about that in a minute. Then we'll get into the basics of Python for a few weeks, all this good stuff. Get into some plotting, lots of plotting, because that's super important, and some numerics and stuff. Then we'll get into more career development stuff. And you'll notice that around week 9 or 8 is when we kind of stop giving you coding homeworks. And then we literally just let you run loose for a month or a month and some change to do a final project. So that's a huge part of the class, and we'll be checking in on you, giving you check-ins to, to make sure that you're doing something. I can't stress this enough. Don't wait till the last day to do or last week to do your project. It doesn't end well. Those projects never work out. You need to spend time over a period, like a longer period of time, not just a week before. When there was 10 people taking this course a couple semesters ago, that was doable because we could pull an all-nighter with you and help you get it done. Now there's 30 to 50 of you. We can't do that anymore. As much as we'd love to help you out and get you to have something great, we can't do that. So please don't expect us to pull an all-nighter with you the last week because you waited too long to start your project. That being said, I just want to say that the final projects in this course are really something special. Last semester, we had people simulating like electrons bouncing off of an atom, Rutherford scattering, if you've ever heard of that before from like chemistry or something. That was pretty cool. We had groups doing like simulations of the solar system, investigating black hole physics. We had groups doing we had like chaotic pendulums with magnetic fields, all sorts of really cool stuff. A group did like a Sudoku solver, which was pretty cool. Exoplanet stuff, it's all there. So the world is your oyster, and it doesn't have to be physics or astronomy related either. Your final project can be anything you deem interesting, but we'll approve it to make sure that it's within the scope of the course and all of that stuff. So be excited for those. Those are a big deal. You could put them on your websites, you could show them to people, and they'll be really impressed, or they won't be, depending on how much work you put into it. But typically, if you put a lot of work into it, you'll get a lot out of it. So that's my advice with that. That's enough about final projects. I don't want to scare you too early. Yeah, so that's all of that good stuff. Let's go ahead and get back to the slides. Is there any questions about the syllabus? Okay, cool. So, like I said, today's goal, don't leave until you have a thing called Jupyter running on your machine. We'll show you what it should look like, but you need to get this running up on your machine in order to leave. This is the layout of the land in terms of what kind of computers y'all have. Half of you have Windows, half of you have Macs. It's typically how it always is. Luckily for you, it doesn't really matter. You just need to download this thing called Anaconda. Super useful. If you already have it installed, good for you, and you know how to use it, then you're in pretty good shape. Just let an instructor or show an instructor when we go into breakout rooms, and you'll be free to go. What is Anaconda? Well, it's a robust data science package. It's used for machine learning. It's used for data analysis and whatever you want to use Python for. We get to use a thing called Jupyter or Jupyter Notebooks, Jupyter Lab, a really nice software. We'll talk more about exactly what it is next week when we get into like the basics of how to interact with Python. But it's just a really cool platform for you to code in bite-sized chunks. So you're not creating giant files that you have to run on the terminal and do all that. You can just kind of code little snippets at a time and work your way with little bite-sized chunks rather than having to code a whole thing. It's a lot more efficient and easy for coding plots and all sorts of stuff like that. So we'll use Jupyter, which is a platform inside of the Anaconda distribution. So if you want to go to Anaconda, if I could have one of my instructors type out this link and post it in the chat, that would be greatly appreciated. Thank you. Go ahead and click on that. You're going to go to a website. It should just take you to something that looks like this on the right. Make sure you download whatever version matches your computer. It should be automatic. Mine was just an Apple right when I got to it because I'm on a Mac. But if you are on a Windows machine, it should be a Windows. Make sure you don't download the Mac if you're on a Windows, and don't download the Windows if you're on a Mac. That would be bad. If I don't think there's anybody here with a Linux machine, but if you had a Linux machine, that's the Penguin. Not super important if you don't. But yeah, make sure that it matches the version you have. Cool. If that does not work out, for whatever reason, this is really for the instructors when we go into the breakout room to help you. There is a backup option. It's called Jupiterhub. It's like a web service that's hosted by UC Berkeley or in collaboration with UC Berkeley. It's free to you if you have a Berkeley account, but it's not very reliable. At least in my experience, it crashes. It depends on Wi-Fi. It's not ideal. Anaconda will be local to your computer. You could use it on a plane. You could use it anywhere. You don't need Wi-Fi to use it, and it doesn't crash on you nearly as badly as Jupiterhub tends to. So this is only a backup option. But I prefer using Anaconda to have a local distribution, but either should work. Yeah. So that being said, I just want to quickly say some Zoom rules. This isn't like super important, but for the 2 weeks that we're on here, respect others, don't talk over others. Please mute yourselves during lectures unless you want to ask questions. Feel free to ask questions or comment in the chat. We encourage you to turn on your videos, all that good stuff. Basically just be good human beings. You all are college students. A lot of you are first, second, third year, fourth year. So this might be your first year in college. Hopefully y'all get the lay of the land now that we're in the spring. Don't be rude. Don't be a high school kid. Just be a college kid. Respectful, all that good stuff. So yeah, anyway, I'm going to make a breakout room now and I'm going to stop recording.